today our note is called the sine and cosine of obtuse angles. Now, so far, everything that you have done has been with acute angles. So now what we're doing is we're looking at obtuse. Now, obviously, if we're just talking about triangles, the largest that we could have would be something that's under 180 degrees in order for us to still have enough for a triangle. Okay. However, what we're doing today will eventually be applied to angles even greater than 180 degrees. Now, the problem with this is we have to redefine everything we know. Well, not everything, but a large portion of what we know and apply it. So first of all, we have defined the trigonometric ratios in terms of the sides of a right triangle. When the amount of rotation exceeds 90 degrees, we relate the angle to a set of coordinates. Okay, so totally different kind of philosophy because we're talking about a set of coordinates. When you hear the word coordinates, you're probably thinking, well, that's the Cartesian plane. And it is the Cartesian plane that we'll be looking at. And when we're talking about sets of coordinates, we're talking about x and y. Now, so the next little part, I just want you to listen and then I'll type some stuff as we go. But in order to do that, let's first start with an x and y axis. Okay, so we have an x, we have our y, and I'll just label them very quickly for us, x. Sorry, I'm writing with my mouse. Doesn't do a great job. So what we're going to do in order to redefine is we're going to create a circle, and we call this the unit circle. The reason it's called a unit circle is it has a radius of 1. So it has a unit of 1. It doesn't matter whether that 1 is 1 mile, 1 centimeter. The point being that it has a radius of 1. So here's my unit circle. I'm going to put it here. Okay, now if you notice I have dotted lines down here, and the reason being that today we're only concerned with going to 180 degrees, but eventually we will go right around that circle. Now I'm going to group this so that it's locked in place for what I need to do. Okay, so here I have this unit circle, and it has a radius of 1 unit. So that means I already do know some points on this circle. And the one point that I know, ooh, those look funky on mine, is this point. That point there, we know if we're talking about a unit circle, that would have coordinates 1, 0. Okay, and I'm going to in a moment label certain ones. So this one I'm going to call point A. So point A has coordinates 1, 0. And again, because it's a unit circle, at the top here I know that that point at the top is going to be 0, 1. And if I keep on going around, this one over here is going to be -1, 0. And finally, at the bottom, I note that this point would be 0, -1. So I haven't done anything really strange there. That should make sense to you. If I have a unit circle, which means the radius is 1, and I draw it on a Cartesian plane, this is what it would have to look like. Now what we're going to do is I need to somehow get an angle. Now what we do is we always start from the center, okay, and I'm going to call that center O, okay, and we also know it has a coordinate of 0, 0. And I'm going to create an angle because I need to have an angle since we're doing trigonometry, obviously. So what I'm going to do is I'm going to have my one arm of my angle on the line OA, and I'm going to take a point P and I'm going to place it, and for now I'm going to place it in the first quadrant for us to talk about. So I'm going to put this point P here, and I don't know for sure what that coordinate is. I know that it will have an x value and it will have a y value. And we'll talk about what those values will be in a moment. So if I create this angle, so the angle theta I'm referring to then is starting here to here. So I will formally define that in the written work in a moment. So this is our theta. Now when I'm looking at this, as I said, I need to redefine things so that if I end up with point P on the other side, I have something to work with. So what we're going to do is we're going to drop a perpendicular, okay, which means a right angle. So we're going to have a right angle because that's something we do know. So I'm going to start at point P and I'm going to drop a perpendicular down to the x-axis. So what we've created here is a right angle triangle. And just so that we can talk, I'm going to name this point where it touches the x-axis, and I'll use a different color. So that point there I'm going to call point N, and what I'm calling it doesn't really matter, but it's N. And what do I know about the coordinates of N? Well, the coordinates, it's going to have an x-coordinate, and its x-coordinate is going to be the same as this x-coordinate of point P, right? Because in order to plot point P, I would go over x units and then up y units. So my point N has coordinates x, 0. Now, having said that, we also know that this point over here will have a value of y that's the same as the value of y coordinate of point P. So now when I look at this, we know an awful lot about this triangle inside here. So I really am kind of concerned with it. And so what I'm going to do is I'm just going to highlight it for a moment so we can talk about it. It's maybe almost too big for us to see, but there we go. I'll do it like this. All right, so this is what I am really concerned about. There's a whole bunch of other things going around because of the circle. So with this, I know I have a right angle triangle. Because I have a unit circle, I know the length of one of these sides. Okay, the side OP, okay, this here, is a radius. okay, because it starts at the center and it touches a point on the circle. So therefore I know that length is 1. I also know the length from 0, from the origin to point N, as being an x value, and the same x value as P. And then opposite the angle, I know this dotted line, this perpendicular, it has a height of y. Because remember, we go over x units, up y units. Okay, so that's what I'm going to put in next. I'm going to put in what we know, and I will do it in blue. So here is our radius, which is 1. I know that the length here is x, and I know the height here, the length of this, is y. Okay, now would you have to reproduce this yourself on a test? No, but you should be able to follow the steps that I'm going through in order to redefine. And I noticed a spelling mistake up here. We're not doing a ration, we're doing a ratio. I'm sure all of you caught that anyways. All right, so here we have this. So I am again going to, in a moment, highlight everything, group it, so at times I can shrink it if we need to be. Come on, group. Okay, yeah, almost. I missed that one piece, so I'll get it grouped as well. Okay, so this is our diagram. As I said, you'll have an opportunity to copy it down because it is important that you understand where I'm getting this information from. At the moment I'm going to shrink it. I will again put it up, or you can restart the video at that one spot in order to get it copied down.